In this video, I am going to show you some practicals on colorful chemistry lesson, that is D block, chemistry of D block elements. You might have seen the colors of aqueous solutions of D block metal cations. As an example, a CO2 plus ion solution is pale blue in color. You can easily make a CO2 plus ion solution by dissolving copper sulfate in water. Right, CO2 plus ion solution is pale blue in color, but a zinc 2 plus ion solution is colorless. Right, now it is very clear that most D block metal cations give colors in aqueous solutions, but some D block metal cations do not show colors in aqueous solutions. Now we are going to see the different colors of these metal cations in aqueous solutions and the reasons for these colors. This is solid copper sulfate. You can dissolve this solid copper sulfate to make a solution like this. It is pale blue in color. This pale blue solution contains CO2 plus ions. So CO2 plus ions are pale blue in color in aqueous solution. Now you see a green color nickel sulfate, solid nickel sulfate, green color. After dissolving this solid, it is possible to make a solution like this. It is green in color. This solution contains Ni2 plus ions. So Ni2 plus ion solution is green color. Now you can see a solution of Cr3 plus ions. It is violet in color. This is solid cobalt chloride. After dissolving this solid, you can make a pink color solution. This pink color solution contains cobalt 2 plus ions. Now you can see a white color solid. It is zinc sulfate. After dissolving zinc sulfate, you can make a colorless solution. This solution contains Zn2 plus ions. Now this is a solution of manganese 2 plus ions, Mn2 plus ions. It is light pink in color. Right, now you can see a solution of ferric ions or Fe3 plus ions. Its color is yellow brown. Fe3 plus ions are yellow brown in color. Some ions formed by some D block metals have partially filled d orbitals. These ions absorb selected range of wavelengths in white light and get excited and show the complementary colors. Right. Some D block metal cations have incompletely filled d orbitals. So they give colors to the aqueous solutions. But some D block metal cations do not have partially filled d orbitals. So they do not show colors in aqueous solutions. Now you have been given some D block elements, actually 3D block elements, scandium 2 zinc. The ions formed by scandium and zinc, they do not show colors in aqueous solutions because they do not have incompletely filled d orbitals. But the ions formed by these elements uh, titanium to copper. They show colors in aqueous solutions due to the presence of incompletely filled d orbitals. Right, this can be explained in detail by considering the electron configurations of these ions. This is the electron configuration of Cu2 plus ion. Okay, now you see the 3D subshell. It has only 9 electrons. It means it is incompletely filled. If it is completely filled, there should be 10 electrons here. But now this has only 9 electrons. So it is incompletely filled. Now you can say that copper 2 plus ions have incompletely filled d orbitals. We can see this in details. Right, again you see the 3D subshell. Here it has 5 orbitals. Right, now you can see clearly this d orbital has only one electron or one unpaired electron. In other words, this orbital is incompletely filled. So you can say that Cu2 plus ions have incompletely filled d orbitals. Due to this, Cu2 plus ions show colors in aqueous solutions. Right, then we will move to Zn2 plus ions. This is the electronic configuration of zinc 2 plus ions. Right, now you can see the 3D subshell of this ion. It is completely filled because it has 10 electrons. Right, then you can say that there is no incompletely filled d orbital here. So you can say that Zn2 plus ions do not give colors to the aqueous solutions. You can see this in details. This indicates the 3D subshell. It has 4 orbitals, d orbitals again, and you can see all the orbitals have been completely filled. Right, now you can understand the reason for the colorless nature of Zn2 plus ion solutions. Now scandium 3 plus ions. This is the electronic configuration of scandium 3 plus ions. You can clearly see that there are no d electrons here and there are no partially filled d orbitals. So scandium 3 plus ions do not show colors in aqueous solutions. Right, you can see the configuration in details. There is no any incompletely filled d orbital here. Okay, in the previous section I explained to you the reason for appearing colors in common. Now I am going to explain the reasons for specific colors of different d-block metal cations in aqueous solutions. You have already known that the color of Cu2 plus ions is pale blue. This is the color pale blue. Cu2 plus ions combine with water molecules to form a complex ion like this in aqueous solution. CuH2O6 2 plus ion, CuH2O6 2 plus ion. hexa aqua copper 2 ion. Now can you say the reason for pale blue color in Cu2 plus ions? Yes, the pale blue color of this solution is due to this complex ion, hexa aqua copper 2 ion. The color of this complex ion is pale blue. Okay, now you can understand that the pale blue color of Cu2 plus ion solutions is due to the presence of hexa aqua copper 2 ion. Okay, now we are going to see the shape and the structure of this complex ion. Okay, this is the structure of hexa aqua copper 2 ion. Its shape is octahedral. Right, you can see that this is the central metal cation Cu2 plus ion. It is surrounded by 6 water molecules. Actually, these water molecules are bonded to this Cu2 plus ion by dative covalent bonds. These water molecules act here as ligands. You can clearly see that each oxygen atom in each water molecule has lone pairs. These lone pairs can be donated to the empty orbitals of this Cu2 plus ion. Right. After that, this oxygen atom and Cu2 plus ion are bonded by dative covalent bond. These arrows show dative covalent bonds. Right. Then this hexa aqua copper 2 ion complex has 6 dative covalent bonds. Right. These covalent bonds are generated between water molecules and Cu2 plus ions. Okay. An aqueous solution of Mn2 plus ions, manganese 2 plus ions, is light pink in color. This is the color, light pink. Mn2 plus ions also bond with water molecules to form this complex ion in the aqueous solution. Mn2O6 2 plus. This is the complex ion formed between Mn2 plus ions and water molecules. Hexa aqua manganese 2 ion. Right, this light pink color is due to this complex ion. This complex ion is responsible for light pink color because the color of this complex ion is light pink. Right, as I mentioned earlier, now we can see the shape and the structure of hexa aqua manganese 2 ion. This is the structure. Here also you have central metal ion Mn2 plus. It is bonded by 6 water molecules with dative covalent bonds. Right, you can see that these water molecules act as ligands. Right, these lone pairs on oxygen atoms can be donated to this Mn2 plus ion, and dative covalent bonds are generated. Here also you can see 6 dative covalent bonds formed between water molecules and Mn2 plus ions. Then we will move to the Fe3 plus ions. Fe3 plus ion solution is yellow brown in color. This is the color. Okay, Fe3 plus ions can also combine with water molecules to form this type of a complex ion. Fe2O6 3 plus or hexa aqua ion 3 complex ion. This yellow brown color is due to this complex ion. Okay, now you can clearly understand the reason for yellow brown color. Okay, we will see the shape and the structure of this complex ion. Same thing happens here. It is also same to the previous one. This also has an octahedral geometry, right? It also has central Fe3 plus ion, and it is surrounded by 6 water molecules. Right, here also water molecules act as ligands. Right, the lone pairs of electrons on oxygen atoms of water molecules are donated to this Fe3 plus ion, and dative covalent bonds are formed. Right, these arrows show dative covalent bonds. There are 6 covalent bonds. Right, now you can clearly understand the reason for the yellow brown color of Fe3 plus ion solutions. Then the aqueous solution of Fe2 plus ions is pale green in color. This is the color of the solution. Fe2 plus ions also form a complex like this with water molecules in the aqueous solution. So it also gives pale green color due to this complex ion. Right, this pale green color is due to this complex ion FeHO6 2 plus or hexa aqua ion 2. Now we can see the shape and the structure of this complex ion also. It is same as the previous ones. Right, you can see you have Fe2 plus central metal cation. It is surrounded by 6 water molecules with 6 dative covalent bonds. Then cobalt 2 plus ions is pink in color in aqueous solution, pink color solution, because these cobalt 2 plus ions also combine with water molecules to form this type of complex ion CO2O6 2 plus or hexa aqua cobalt 2 ion. Right, this complex ion is responsible for giving this pink color to the solution. Right, the color of this complex ion is pink. Okay, now you can explain the reason for this pink color. If we move on to the shape and the structure of hexa aqua cobalt 2 complex ion, it also looks like the previous ones. You can see Cobalt 2 plus ion is the central metal cation. It is bonded by 6 covalent J2 covalent bonds with 6 water molecules. Right. Its shape is also octahedral. Then aqueous solution of a nickel 2 plus ion solution is green in color. Green color. Right. This is the color, green color. Ni2 plus ions can combine with water molecule to form this complex ion Ni2O6 2 plus. The color of this complex ion is green, so it gives the color to this aqueous solution. Okay, now you can say the reason for this green color is the presence of Ni2O6 2 plus or hexaaqua nickel 2 ion. This is the structure of hexaaqua nickel 2 ion, and its geometry is octahedral. The structure is same to the previous ones. Ni2 plus ions are surrounded by 6 water molecules with 6 dative covalent bonds. Then the color of Cr3 plus ion solution is violet. This color, violet color. Chromium 3 plus ions also forms a complex ion like this with water molecules. Color of this complex ion is violet. So this violet color is due to this complex ion. Okay, Cr2O6 3 plus or hexaaqua chromium 3 ion. This is the IUPAC name of this complex ion. The shape of the complex is octahedral and the structure is given like this. It is also same to the previous ones I described. Then an aqueous solution of Zn2 plus ions is colorless. Now you know the reason is right. Okay, reason is very clear. This is the solution, colorless. Zinc 2 plus ions also form a complex ion with water molecules. Right, this complex ion is colorless. Zn2O6 2 plus complex ion, it is colorless. This colorless nature is due to this complex ion. Its IUPAC name is hexaaqua zinc 2 ion. The shape of this complex ion is octahedral again, and the structure is also same to the previous complexes. You have Zn2 plus central metal ion, and it is surrounded by 6 water molecules. These are ligands. Each water molecule has lone pair of electrons. This lone pair of electrons can be donated to the empty orbitals of Zn2 plus ions by forming dative covalent bonds. You have 6 dative covalent bonds formed between these oxygen atoms and Zn2 plus ion. Okay, Shape of this complex is also octahedral. I just explained the reasons for giving specific colors by D-block metal cations in aqueous solutions. We will meet in another video like this. So you may subscribe this channel to see this type of videos. Thanks for watching.